Well, hello, Internet, and welcome to part 8 of my Python for Finance video tutorial series. In the last video, I showed you how to create efficient portfolios using the Markowitz Portfolio Optimization technique. And then we looked at the Sharpe Ratio. What I'm going to do in this video is we are going to search the entire market so that we can create the most optimized portfolios to maximize return while minimizing your overall risk. I'm going to talk again more about the Sharpe Ratio, and then I'm also going to show you how to automatically generate the optimized weighting to create your portfolios so that you know exactly how many shares to buy. And I have a lot to do, so let's get into it. All right, so previously in part 4, I showed you how to go and find those sector stocks, being stocks that fit into certain sectors, being technology, healthcare, financials, and all these other different ones, and then find those who had the highest ROI. Now, our job here is to try to create like a super portfolio. So what I did was I took the top 30 or more of these different sector stocks, plugged them in, and I had about 400 different stocks, and you can see the tickers and all that. And then from that point, what I did was I had, I generated portfolios like I did previously in the last video, efficient portfolios that maximize return and minimize risk. Well, then what I did was in those situations, because I want this portfolio to be small, I don't want to buy 400 stocks, I might as well just go and get an index if I want to do that. So what I wanted to do was I got the list of securities, and let's say that after I ran the test, I had 40 of them. Well, in situations in which I had stocks that were, quite a bit under 1% allocation-wise, I eliminated them. And then I ran my tests again to create another efficient portfolio. And I did this over and over and over again until I got this core group of stocks that showed great return. All right, and I'm not just going to show you code here. I'm going to actually write code, because what I'm going to do after this is, after it gives you a recommendation for the securities to purchase and the percentages to purchase, I'm going to show you, or I'm going to create a whole bunch of functions that are going to allow you to automatically generate how many shares you need to buy to approximate the efficient portfolio, okay? So everything else here is exactly the same as the last video. Here are all of the prices changes for all of our different securities, and this is the updated list, the brand new list of best, at least, based off of my calculations. And again, we have a new plot here with all of our different securities starting at 100, so you can see that growth. And all of this code is, of course, this whole entire file and everything here is on GitHub for free. It's in the description, so if you want to look at it, it'll help a lot. Okay, I went and got mean returns, just like before, covariances, to make sure that we have non-correlated assets in our portfolio. And more importantly, correlation shows this a lot better. So what we want to do is try to get assets that are below 0.5 in all of these different columns as much as humanly possible. And that is going to make our portfolio less risk adverse. And here what I did was generate random weights. Here is the return of the portfolio. There is the volatility of the portfolio. And you can see here, this is when I was generating all those. There is the efficient frontier with all those 10,000 different portfolios made up of those individual securities. And then we applied the Sharpe Ratio again, just like we did in the last video. And from that, we were able to generate the key great portfolio that matches closest with this. And you can see here we have a 24 volatility and a return of 37.9. Let's see if we can find that here. So 24 and 37 point. I'm guessing it is this guy right here. And you can see it is way off of there. Okay, so that is definitely a very efficient portfolio. All right, so what are we going to do now? Well, our goal here now is we know what percentages to buy for each of these securities. Well, the only problem is every single security isn't priced at the same price. They're all over the place. And what we need to do is we need to come in here and actually figure out how much or how many shares of each of these securities we need to buy to get close to 24.72, for example. Okay, and that's the percentage that we need of the GNRC stock, 16% for the next, 6.8, da-da-da. So what I'm going to do is I'm going to create a function that is going to do that. Now, every single time I run this code, I get a slightly different portfolio. So I decided to use this mixture of securities. And what I want to do here is I want to try and get as close as possible buying individual shares of these securities. Yes, I know you can buy fractional shares, but this is something that a question that was requested of me, and I'm going to fulfill it. Okay, so what we're going to do here, first, I want to think about, like what's going on. So PG stock is very close to 1. So I'm just going to say it's 1. All right, and this doesn't have to be perfect, but as you're going to see, my function is going to be doggone close to being perfect, okay? So if I'm off by 0.09%, that's not really going to affect the overall risk and return of this portfolio. All right, so what do we have? Well, we have 118. This is what our function is going to do. It's going to take 118, and because that represents the price for PG stock, and it's going to multiply it times 22. So times 22. I'm explaining the code that I'm going to create. Now, if we do this, we get 2600.4. And then what we want to do is we want to divide that by the value of the GNRC stock, which is priced at 102.01. Now, if we do that, what we're going to get is an answer of 25.49. So that means to approximate, based off of Procter & Gamble being 1% and this being almost 22, what we want to do is figure out how many shares of GNRC we need to buy to, meet our requirement of getting 22%. Well, the answer to that is 25 shares. Okay? And then what we need to do is just simply multiply that times 102.01. And whenever we do that, that will give us the total amount that we are going to invest in GNRC stock. All right? So, and in situations in which we, like for example, COG or I think Charter causes some problems because of its price. In situations in which prices just will not work, what I'm going to do with our function is I'm going to say, guarantee we get at least one of those securities. All right? And let's see how it works out. All right? So I'm going to create basically everything you see right here, down here, in a way that is going to work with an entire portfolio. So I'm going to call this get port shares like this. And this is going to represent the price of the 1% stock. So PG stock is going to be passed inside of here, and it's going to be used as a model right here. Okay? So we're going to get past that value. And what else are we going to pass? Well, do we want to force that we definitely will get at least one share of each security? Well, they can either make this true or false. It is up to them. Then we're going to get an array of weights that we are trying to aim for, and an array of prices. Okay, so now that we have that, I'm going to keep this on the board because basically what I'm doing is I'm modeling this calculation down here in the code. All right, so what I want to do first is I want to find out the number of stocks that we are going to be analyzing. And to do that, I can just go equals length and weights, exactly like that. All right, then I am going to create a list, and it's going to hold the number of shares for each of those securities. This is going to be an updating list. I am then also going to have the costs for those securities also updated. And then I'm going to say I is equal to, and I'm going to cycle through the weights and the prices and figure this stuff out. So I'm going to say while I is less than the number of stocks that we want to analyze. Well, I want to get the maximum amount to spend on a stock, and I'm just going to call this max price, and that's going to be equal to whatever the value is of the P&G stock that was passed in. I think you can see right here how I'm basically just modeling this. That's what's going on. Then what I'm going to do is I'm going to get my weighting, and that is going to update. Whoops. I don't like that there. Okay. Times the weights, and they're going to update each time. Then what I want to do is get the number of shares to buy and add that to the list. So I'm going to say the number of shares that I need to buy to be able to get as close as possible to that recommended allocation. So to do that, I'm going to convert this answer into an integer because you can't buy fractions of a share, at least in my world. And I'm going to say that is going to be divided by whatever the price is for that security. Now what we can do is we can say if the user wants us to always have at least one security and the number of shares after this calculation is equal to 0, well, in that situation, I'm going to mark the number of shares equal to 1. All right, so that guarantees we have at least one share of every single security, and we'll see how that works out. Okay, then I want to append the number of shares to buy for that security to our shares list, and then I want to get the cost of those shares and append that to a list. So to do so, I go cost is equal to the number of shares times the prices I, like that. And then I'm going to say cost and shares and append that cost to it. Okay. And then I have to, of course, increment the value of I to get the next security. And then after I'm done with that, I can return both. So I'm going to say return the list, which is shares that I need to buy, and the cost per shares. Okay? So there we go. Got that function. Well, now what I want to do is I want to get my portfolio weighting. So I'm going to create another function here, and it's going to say get port and weighting, and I'm going to be passing in share cost into that, and I'm going to create another list, and this guy weights like this. This is just an empty list that's going to be populated. I am going to go and I'm going to need to go and get the total sum of all the investments in the portfolio. So total, and I just call sum on the share cost, and it'll give me the total sum of all the different stocks in that list. And I can come in here and maybe I want to print that information out. So I'll say total investment. So this is going to say the total investment the user is going to have to make with this portfolio to get this allocation. Then all I do is I just say for X in and share cost like that, and stock weights and append, and what I can append is just X divided by whatever the total value of the portfolio is. And then after I do all of that for all those different securities, I can say that I want to return the stock weights. All right. Now I was going to show you the value of the portfolio by date, but I'm going to leave that till the next video because it makes more sense then. Okay, so we have our list of securities right here, this that we went and condensed down into the core stocks we want to buy. And then on top of that, I have the weightings that I want for each of those securities. And all I did was I rounded these numbers. So 21.9 became 22, 16 became this, and so forth and so on. So now what we're going to do is we're going to use our functions that we just created to come in here and see if how many shares we need to buy of each of the individual securities to get these percentage weightings. All right, so pretty good stuff. So what I'm going to do is I'm going to say that I want to create a starting. What I want to do is just get all stock prices on my starting date. So I'm going to go port df start is equal to merge and data frame by column name, which is a function I created forever ago in past videos. So adjusted close, and I'm going to get a specific price. All I do is I pass in one date instead of passing in two dates. So I have 20. This is the very first trading day of 2021 or 2020. So let's throw that there. and I am going to throw in my portfolio list. So that is generating that data frame. Then what I need to do is I need to convert from this data frame to a regular old Python list. So I'm going to call this port prices, portfolio prices obviously, and go port data frame start, and then you call values, and then you say to list like this, and it's going to create that list. The only problem is it's going to create a list inside of a list. We don't want that. We just want a list. So there's a trick. You can just go port prices is equal to sum like that, and this will convert it into a simple Python list. And you just pass in port prices like that and an empty array, and that will give us exactly what we want. All right, so now what I want to do is I want to go and call get port shares, this guy right here. I'm going to pass in the one price, which is going to be the price for PG stock. I'm going to say, yes, I want to demand that I get at least one of every single security. And then I pass in two arrays. One of the arrays is the weights for the securities and the prices for said securities. And then it's going to provide me the information that I want. So it is going to provide, the total shares that I need to buy to get my allocation that I'm looking for. And it's also going to provide share cost passed back to me. So I just go get port shares like this. 118, once again, is the value of Procter & Gamble stock that we're going to use as a baseline for making predictions about all of our other securities. And then we're going to pass in our weights and our prices exactly like that. Okay, so now what do we got? We got all our information. We just need to test it to see if it matches with what we want percentage-wise. So if I want to print out the shares that I need to buy of each security to try and get as close as humanly possible to that, well, that's what that's going to do. And then I can also go share cost if I want to print out that as well. And I just go share cost like that. And what else do we need? I am going to go and get a list of the weights for the stock. So I'll say stock and weights is equal to get port weighting like this, and pass in the share cost like that. And then I can go and print this out. This will be the weights for all of them. So I'll just say stock and weights, and then I can go stock weights like this. And then if I think that's good. All right, so let's just keep that there. Let's run it, see if it worked. Actually, I think there was one error in my code that I corrected without thinking, and it was right here. I accidentally, whenever I was showing you, I accidentally had a W right there, so make sure you put an X right there. Okay, so now let's test our results. So these were the percentages we were aiming at, and let's see how close we got with our weightings. So we wanted 21.9 of GNRC stock, and we got 21.7. We wanted 15.6, we got 15.9. We wanted 23, we got 23.8. And as you can see, everything is working itself out just about perfectly. Okay, so there you go, guys. Now you know how to take a mountain of stock, how to combine them, analyze them, find non-correlated assets, combine them into gigantic high return, low risk portfolios. And you also know how many shares to buy to get this target allocation of stocks. So hopefully you find this beneficial and useful. And like always, please leave your questions and comments down below. Otherwise, till next time.